Certified Kubernetes Administrators course. In this lecture, we discuss about cluster maintenance related topics. We start by looking at operating system upgrades. We see the implications of losing a node from the cluster, or when you take a node out of the cluster on purpose, like for applying patches or upgrades on the OS itself. We then look at the cluster upgrade process, but before we do that, we need to know a little bit about Kubernetes releases and versions, and the best practices around upgrading, when to upgrade, what version to upgrade to, etc. So we look at that first. Once you learn the upgrade procedure, you are asked to upgrade a cluster by yourself. You will perform an end-to-end upgrade of a cluster yourself with live applications running on them. And finally, we look at some of the backup and restore methodologies. You will practice a disaster recovery scenario where you take a backup of the Kubernetes cluster, then go through a simulated disaster, and then you're asked to recover from that disaster and bring the cluster back to the previous state. Well, fun stuff coming up, so let's get started. Hello and welcome to this lecture. In this lecture, we will discuss about scenarios where you might have to take down nodes as part of your cluster, say for maintenance purposes, like upgrading a base software or applying patches like security patches, etc. on your cluster. In this lecture, we will see the options available to handle such cases. So you have a cluster with a few nodes and pods serving applications. What happens when one of these nodes go down? Of course, the pods on them are not accessible. Now, depending upon how you deployed those pods, your users may be impacted. For example, since you have multiple replicas of the blue pod, the users accessing the blue application are not impacted, as they are being served through the other blue pod that's online. However, users accessing the green pod are impacted, as that was the only pod running the green application. Now, what does Kubernetes do in this case? If the node came back online immediately, then the kube control process starts and the pods come back online. However, if the node was down for more than 5 minutes, then the pods are terminated from that node. Well, Kubernetes considers them as dead. If the pods were part of a replica set, then they are recreated on other nodes. The time it waits for a pod to come back online is known as the pod eviction timeout and is set on the controller manager with a default value of 5 minutes. So whenever a node goes offline, the master node waits for up to 5 minutes before considering the node dead. When the node comes back online after the pod eviction timeout, it comes up blank without any pods scheduled on it. Since the blue pod was part of a replica set, it had a new pod created on another node. However, since the green pod was not part of a replica set, it's just gone. Thus, if you have maintenance tasks to be performed on a node, if you know that the workloads running on the node have other replicas, and if it's okay that they go down for a short period of time, and if you're sure the node will come back online within 5 minutes, you can make a quick upgrade and reboot. However, you do not for sure know if a node is going to be back online in 5 minutes. Well, you cannot for sure say it is going to be back at all. So there is a safer way to do it. You can purposefully drain the node of all the workloads so that the workloads are moved to other nodes in the cluster. Well, technically, they're not moved. When you drain a node, the pods are gracefully terminated from the node that they're on and recreated on another. The node is also cordoned or marked as unschedulable, meaning no pods can be scheduled on this node until you specifically remove the restriction. Now that the pods are safe on the other nodes, you can reboot the first node. When it comes back online, it is still unschedulable. You then need to uncordon it so that the pods can be scheduled on it again. Now remember, the pods that were moved to the other nodes don't automatically fall back. If any of those pods were deleted, or if new pods were created in the cluster, then they would be created on this node. Apart from drain and uncordon, there is also another command called cordon. Cordon simply marks a node unschedulable. Unlike drain, it does not terminate or move the pods on an existing node. It simply makes sure that new pods are not scheduled on that node. Well, that's it for this lecture. Head over to the practice test and practice draining, cordoning, and uncordoning a node. I will see you in the next lecture. Hello and welcome to this lecture. In this lecture, we will discuss about the various Kubernetes releases and versions. So what do we know about API versions in Kubernetes so far? We know that when we install a Kubernetes cluster, we install a specific version of Kubernetes. We can see that when we run the kubectl get nodes command. In this case, it's version 1.11.3. In this lecture, we will see how Kubernetes project manages these software releases. Let's take a closer look at that version number. The Kubernetes release versions consist of three parts. The first is the major version, followed by the minor version, and then the patch version. While minor versions are released every few months with new features and functionalities, patches are released more often with critical bug fixes. Just like many other popular applications out there, Kubernetes follows a standard software release versioning procedure. Every few months, it comes out with new features and functionalities through a minor release. The first major version, 1.0, was released in July of 2015. As of this recording, the latest stable version is 1.13.0. Whatever we have seen here are stable releases of Kubernetes. Apart from these, you will also see alpha and beta releases. All the bug fixes and improvements first go into an alpha release tagged alpha. In this release, the features are disabled by default and may be buggy. Then from there, they make their way to beta release, where the code is well tested, the new features are enabled by default, and finally, they make their way to the main stable release. You can find all the releases in the releases page of the Kubernetes GitHub repository. Download the kubernetes.tar.gz file and extract it to find executables for all the Kubernetes components. The downloaded package, when extracted, has all the control plane components in it, all of them of the same version. Remember that there are other components within the control plane that do not have the same version numbers. The etcd cluster and core DNS servers have their own versions as they are separate projects. The release notes of each release provides information about the supported versions of externally dependent applications like etcd and core DNS. Check out the links for some references. That was a quick overview of the release versions. In the upcoming lecture, we will discuss how to upgrade from one version to another. Hello and welcome to this lecture. In this lecture, we discuss about cluster upgrade process in Kubernetes. In the previous lecture, we saw how Kubernetes manages its software releases and how different components have their versions. We will keep dependency on external components like etcd and core DNS aside for now and focus on the core control plane components. Is it mandatory for all of these to have the same version? No, the components can be at different release versions. Since the Kube API server is the primary component in the control plane, and that is the component that all other components talk to, none of the other components should ever be at a version higher than the Kube API server. The controller manager and scheduler can be at one version lower. So if Kube API server was at X, controller managers and Kube schedulers can be at X-1, and the kubelet and kube proxy components can be at two versions lower, X-2. So if Kube API server was at 1.10, the controller manager and scheduler could be at 1.10 or 1.9, and the kubelet and kube proxy could be at 1.8. None of them could be at a version higher than the Kube API server, like 1.11. Now this is not the case with kube control. The kube control utility could be at 1.11, a version higher than the API server, 1.10, the same version as the API server, or at 1.9, a version lower than the API server. Now this permissible skew in versions allows us to carry out live upgrades. We can upgrade component by component if required. So when should you upgrade? Say you were at 1.10 and Kubernetes releases versions 1.11 and 1.12. At any time, Kubernetes supports only up to the recent 3 minor versions. So with 1.12 being the latest release, Kubernetes supports versions 1.12, 1.11, and 1.10. So when 1.13 is released, only versions 1.13, 1.12, and 1.11 are supported. Before the release of 1.13 would be a good time to upgrade your cluster to the next release. So how do we upgrade? Do we upgrade directly from 1.10 to 1.13? No. The recommended approach is to upgrade one minor version at a time. Version 1.10 to 1.11, then 1.11 to 1.12, and then 1.12 to 1.13. The upgrade process depends on how your cluster is set up. For example, if your cluster is a managed Kubernetes cluster deployed on cloud service providers like Google, for instance, Google Kubernetes Engine lets you upgrade your cluster easily with just a few clicks. If you deployed your cluster using tools like kubeadm, then the tool can help you plan and upgrade the cluster. If you deployed your cluster from scratch, then you manually upgrade the different components of the cluster yourself. In this lecture, we will look at the options by kubeadm. So you have a cluster with master and worker nodes running in production, hosting pods, serving users. The nodes and components are at version 1.10. Upgrading a cluster involves two major steps. First, you upgrade your master nodes and then upgrade the worker nodes. While the master is being upgraded, the control plane components such as the API server, scheduler, and controller managers go down briefly. The master going down does not mean your worker nodes and applications on the cluster are impacted. All workloads hosted on the worker nodes continue to serve users as normal. Since the master is down, all management functions are down. You cannot access the cluster using kube control or other Kubernetes API. You cannot deploy new applications or delete or modify existing ones. The controller managers don't function either. If a pod was to fail, a new pod won't be automatically created. But as long as the nodes and the pods are up, your applications should be up and users will not be impacted. Once the upgrade is complete and the cluster is back up, it should function normally. We now have the master and the master components at version 1.11 and the worker nodes at version 1.10. As we saw earlier, this is a supported configuration. It is now time to upgrade the worker nodes. There are different strategies available to upgrade the worker nodes. One is to upgrade all of them at once. But then your pods are down and users are no longer able to access the applications. Once the upgrade is complete, the nodes are back up, new pods are scheduled, and users can resume access. That's one strategy that requires downtime. The second strategy is to upgrade one node at a time. So going back to the state where we have our master upgraded and nodes waiting to be upgraded, we first upgrade the first node, where the workloads move to the second and third node and users are served from there. Once the first node is upgraded and back up, we then update the second node where the workloads move to the first and third nodes. And finally, the third node where the workloads are shared between the first two. Until we have all nodes upgraded to a newer version, we then follow the same procedure to upgrade the nodes from 1.11 to 1.12 and then 1.13. A third strategy would be to add new nodes to the cluster. Nodes with newer software version. This is especially convenient if you're on a cloud environment where you can easily provision new nodes and decommission old ones. Nodes with the newer software version can be added to the cluster, move the workload over to the new, and remove the old node, until you finally have all new nodes with the new software version. Let us now see how it is done. Say we were to upgrade this cluster from 1.11 to 1.13. kubeadm has an upgrade command that helps in upgrading clusters. With kubeadm, run the kubeadm upgrade plan command and it will give you a lot of good information. The current cluster version, the kubeadm tool version, the latest stable version of Kubernetes. Then it lists all the control plane components and their versions and what version these can be upgraded to. It also tells you that after we upgrade the control plane components, you must manually upgrade the kubelet versions on each node. Remember, kubeadm does not install or upgrade kubelets. Finally, it gives you the command to upgrade the cluster. Also note that you must upgrade the kubeadm tool itself before you can upgrade the cluster. The kubeadm tool also follows the same software version as Kubernetes. So we're at 1.11 and we want to go to 1.13. But remember, we can only go one minor version at a time. So we first go to 1.12. First, upgrade the kubeadm tool itself to version 1.12. Then upgrade the cluster using the command from the upgrade plan output, kubeadm upgrade apply. It pulls the necessary images and upgrades the cluster components. Once complete, your control plane components are now at 1.12. If you run the kubecontrol get nodes command, you will still see the master node at 1.11. This is because in the output of this command, it is showing the versions of kubelets on each of these nodes registered with the API server, and not the version of the API server itself. So the next step is to upgrade the kubelets. Remember, depending on your setup, you may or may not have kubelets running on your master node. In this case, the cluster deployed with kubeadm has kubelets on the master node, which are used to run the control plane components as pods on the master nodes. When we set up a Kubernetes cluster from scratch later during this course, we do not install kubelet on the master nodes. You will not see the master node in the output of this command in that case. So the next step is to upgrade kubelet on the master node, if you have kubelets on them. Run the apt-get kubelet command for this. Once the package is upgraded, restart the kubelet service. Running the kubecontrol get nodes command now shows that the master has been upgraded to 1.12. The worker nodes are still at 1.11. So next, the worker nodes. Let us start one at a time. We need to first move the workloads from the first worker node to the other nodes. The kubecontrol drain command lets you safely terminate all the pods from a node and reschedules them on the other nodes. It also cordons the node and marks it unschedulable. That way, no new pods are scheduled on it. Then upgrade the kubeadm and kubelet packages on the worker nodes as we did on the master node. Then using the kubeadm tool upgrade command, update the node configuration for the new kubelet version. Then restart the kubelet service. The node should now be up with the new software version. However, when we drained the node, we actually marked it unschedulable. So we need to unmark it by running the command kubecontrol uncordon node 1. The node is now schedulable, but remember that it is not necessary that the pods come right back to this node. It is only marked as schedulable only when the pods are deleted from the other nodes, or when new pods are scheduled do they really come back to this first node. Well, it will soon come when we take down the second node to perform the same steps to upgrade it. And finally, the third node. We now have all nodes upgraded. Well, that's it for this lecture. Head over to the practice test where you will practice upgrading a live cluster with applications running on it without taking the applications down. Good luck.
In this video, I'm going to walk you through the upgrade process for upgrading a Kubernetes cluster. And so first, we're going to have to get a Kubernetes cluster running a version that isn't the latest version. And then I'm just for upgrading a Kubernetes cluster. And so first, we're going to have to get a Kubernetes cluster running a version that isn't the latest version. And so if you go to the Code Cloud webpage, you could go to a playgrounds and we could spin up a Kubernetes cluster using one of the pre-built playgrounds. And so we'll just scroll down to Kubernetes playgrounds, and we want to make sure we don't grab the latest one. So that's going to give us the latest version. We want to grab one that's a little bit older. So right now, at the moment, the oldest one we have is 1.24. So I'm going to use that. If you're watching this video in the future, it might be 1.25 or 1.26. And then I'm just select launch now, and that's going to prepare our lab environment. So the lab environment has been set up and is up and running, and let's just verify how many nodes and what kind of nodes we have running in our playground. So if I run a kubectl get node, we can see that there's two different nodes. We've got a control plane node and we've got node 1, and we can see that they're both running version 1.24.0. So now that we have that information, let's go to the Kubernetes documentation, and we're going to go to the upgrading kubeadm clusters. And we're going to find the specific instructions for upgrading from version 1.24. And so you can see here we've got going from 1.22 to 1.23, 1.23 to 1.24, and then 1.24 to 1.25. So this is the one we're going to do. Remember, you have to upgrade one version at a time. So in this demo, we're going to upgrade from 1.24 to 1.25. So I'll select this, and that's going to take us to the instructions for upgrading between those two specific versions. I'm going to go down, and the first thing that we're going to have to do is verify what distribution our nodes are using. So I'm going to run a cat/etc/star-release star, and we can see here that we are in fact running Ubuntu. So we're going to follow all of the Ubuntu instructions. So we're going to run an apt update, and then we're going to run this command. So this is going to help us find what is the latest version of 1.25. So it's going to look something like this, but there'll be some number here. And so I'll just copy and paste these. All right, so that's going to spit out all of the versions. We want to look for 1.25. And we can see all of the 1.25 starting here. So we got 1.25.0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 is the latest one because the next one is 1.260. So just jot this down in your notes. We're going to be upgrading everything to 1.25.10-00. So the next thing that we're going to do is, now that we got the version, we're going to upgrade the control plane node first. As mentioned in the lecture, we always want to upgrade the control plane first, and then we'll move on to the worker node. And so the first thing that we're going to do when it comes to upgrading the control plane node is upgrading kubeadm. So we're going to take this, we're going to copy these commands, but we just have to swap it out with the version that we got from this output here. So instead of 1.25.x, we're going to do 1.25.10. All right, so I've got this pasted in my notes. I'm going to just swap out the x with the 10. We can just copy this command now and paste it into the terminal. So once we've upgraded the kubeadm, let's just verify that it is in fact running the version that we specified. So I'll do kubeadm version, and we can see that it's running at version 1.25.10. All right, so now we're going to run a kubeadm upgrade plan. So this is going to list out the version of all of our different components across all the nodes, as well as what versions we can upgrade them to. And so if I go up here, we can see that right now the cluster version is 1.24.0. We can see the kubeadm version is version 1.25.10. It also mentions that components that must be upgraded manually. So all the kubelet components, kubeadm doesn't upgrade them. You have to do those manually. And so this is going to show you the versions that you can upgrade all the different components to if you want to go to the latest version in the 1.24 series, but we want to go to 1.25. So if you keep scrolling down, you'll see all the information regarding that. So we can upgrade the kubelet to 1.25.10, and the same thing goes for all of the other components. And so if you want to upgrade it, you just run kubeadm upgrade apply version 1.25.10. So we'll run that command. We'll do sudo kubeadm upgrade apply version 1.25.10. And we'll hit yes. All right, so now after that's completed, we can see that the upgrade was successful, and we've successfully upgraded to version 1.25.10. Now, if I run a kubectl get node, you're going to see that it still reports version 1.24.0. So why is it saying that when it said the upgrade was successful? That's because the version that's outputted here is going to be the kubelet version. And so kubeadm doesn't upgrade kubelet for us. We have to do that manually ourselves. And so that's what this is reporting. But all of the other components have been upgraded to 1.25.10. So now if we continue following the instructions, it's just letting us know if you have a CNI provider plugin, you're going to have to upgrade that. We don't have that. And if you have other control plane nodes, you go ahead and run sudo kubeadm upgrade node on them, and that should do the same process on those nodes. We just have one control plane node, so we don't need to worry about that. But now we're going to upgrade the kubelet process. And keep in mind, in our specific playground here, we happen to have a kubelet process running on the control plane node. It may not, the control plane nodes may not always have a kubelet process running depending on how you've configured it and how you've set it up. So just double check, verify if you have kubelet running on your control plane node. If you do, you're going to have to follow these steps. So the first thing is we're going to have to prepare the node for maintenance. So we're going to drain the node. And so we're going to run this command right here. Just swapping out the node name with control plane. So I'll do kubectl drain control plane -- ignore daemon sets. All right, and so we can see if I run a kubectl get node, we can see scheduling is disabled. So that just prepared this control plane node for maintenance so that we can upgrade the kubelet process. And so we'll go down in the instructions, and we can see here, it's going to give us the instructions for Ubuntu. We're going to just copy this. I'm going to open up my notepad, paste it in, and just swap out the version. So this is going to be 10, and this is going to be 10. So we'll copy this, paste it. And so now we're going to restart the kubelet process. So I'll do sudo systemctl daemon reload, and then we'll do a sudo systemctl restart kubelet. So now if I do a kubectl get node, we can see that the control plane node, the kubelet process has been upgraded. But right now we can still see scheduling is disabled. So we're going to have to uncordon the node. So I'll do kubectl uncordon control plane. And now if I do a kubectl get node, we can see that it's ready and it's on version 1.25.10. And so that's going to complete the process of upgrading the control plane node. Let's now move on to the worker nodes. So in the playground, let's go to the worker node. So if you want, you can always open up a new terminal. And if I do a kubectl get node, we can see the node is called node 1, so I can just do SSH node 01, and that's going to get us to node 1. All right, so now on the worker node, we're going to have to do similar things. We're going to have to upgrade kubeadm, so we'll copy this command and change it to 125.10. And once kubeadm has been upgraded, we'll run the command kubeadm upgrade node. And so as we can see in the instructions, the configuration for this node was successfully updated. And the next thing that we have to do is upgrade the kubelet package. And so before we upgrade the kubelet, we're going to drain the node. So we'll run this command kubectl drain and then the name of the node. Keep in mind that this command has to be run on the control plane, not on the worker node. So we'll go back to the control plane and I'll run this command. So now if I do a get node, we should see scheduling disabled. And then now we can upgrade the kubelet and kubectl. So I'll copy this. And we'll change this to 10 and 10. So once that's done, we're going to restart the kubelet process. And so now if I do a kubectl get node, we'll go back to the control plane, kubectl get node. We can see that it's been upgraded to version 125.10, and we need to uncoordinate it. So we'll do kubectl uncoordin node 1. So now we can see the worker and the control plane node upgrade to version 125.10, and both are in a ready state. And so that's going to wrap up this video. That's how we upgrade a Kubernetes cluster using kubeadm.
Hello and welcome to this lecture. In this lecture, we look at the various backup and restore methodologies. Let's start by looking at what you should consider backing up in a Kubernetes cluster. So far in this course, we have deployed a number of different applications on our Kubernetes cluster using deployment, pods, and service definition files. We know that the etcd cluster is where all cluster-related information is stored. And if your applications are configured with persistent storage, then that is another candidate for backups. With respect to resources that we created in the cluster, at times we use the imperative way of creating an object by executing a command, such as while creating a namespace or a secret or config map, or at times for exposing applications. And at times, we used the declarative approach by first creating a definition file and then running the kubectl apply command on that file. This is the preferred approach if you want to save your configuration, because now you have all the objects required for a single application in the form of object definition files in a single folder. This can easily be reused at a later time or shared with others. Of course, you must have a copy of these files saved at all times. A good practice is to store these on source code repositories. That way it can be maintained by a team. The source code repository should be configured with the right backup solutions. With managed or public source code repositories like GitHub, you don't have to worry about this. With that, even when you lose your entire cluster, you can redeploy your application on the cluster by simply applying these configuration files on them. While the declarative approach is the preferred approach, it is not necessary that all of your team members stick to those standards. What if someone created an object the imperative way without documenting that information anywhere? So a better approach to backing up resource configuration is to query the Kube API server. Query the Kube API server using the kube control or by accessing the API server directly and save all resource configurations for all objects created on the cluster as a copy. For example, one of the commands that can be used in a backup script is to get all pods and deployments and services in all namespaces using the kube control utilities getAll command and extract the output in a YAML format. Then save that file. And that's just for a few resource groups. There are many other resource groups that must be considered. Of course, you don't have to develop that solutions yourself. There are tools like Arc, or now called Velero by Heptio, that can do this for you. It can help in taking backups of your Kubernetes cluster using the Kubernetes API. Let us now move on to etcd. The etcd cluster stores information about the state of our cluster. So information about the cluster itself, the nodes, and every other resources created within the cluster are stored here. So instead of backing up resource as before, you may choose to back up the etcd server itself. As we have seen, the etcd cluster is hosted on the master nodes. While configuring etcd, we specified a location where all the data would be stored, the data directory. That is the directory that can be configured to be backed up by your backup tool. etcd also comes with a built-in snapshot solution. You can take a snapshot of the etcd database by using the etcd control utility's snapshot save command. Give the snapshot a name, snapshot.db. A snapshot file is created by the name in the current directory. If you want it to be created in another location, specify the full path. You can view the status of the backup using the snapshot status command. To restore the cluster from this backup at a later point in time, first stop the Kube API server service, as the restore process will require you to restart the etcd cluster and the Kube API server depends on it. Then run the etcd controls snapshot restore command with the path set to the path of the backup file, which is the snapshot.db file. When etcd restores from a backup, it initializes a new cluster configuration and configures the members of etcd as new members to a new cluster. This is to prevent a new member from accidentally joining an existing cluster. On running this command, a new data directory is created. In this example, at location var lib etcd from backup. We then configure the etcd configuration file to use the new data directory. Then reload the service daemon and restart etcd service. Finally, start the Kube API server service. Your cluster should now be back in the original state. A quick note before I let you go. With all the etcd commands, remember to specify the certificate files for authentication, specify the endpoint to the etcd cluster and the CA certificate, the etcd server certificate, and the key. So we have seen two options, a backup using etcd and a backup by querying the Kube API server. Now both of these have their pros and cons. Well, if you're using a managed Kubernetes environment, then at times you may not even have access to the etcd cluster. In that case, backup by querying the Kube API server is probably the better way. Well, that's it for this demo. Head over to the practice test and practice backing up etcd in a cluster and then restoring from backups. Okay, so let us now look at the backup and restore.
So for the first question is just letting us know that we're going to be working with multiple Kubernetes clusters where we'll be able to practice backing up and restoring etcd databases. And so here is just letting us know that we're currently logged into the student node instead of the control plane for one of the clusters. And the student node has a kubectl client already installed so that it can access the Kubernetes clusters in the environment. So just go ahead and poke around and take a look. So if I just do a kubectl get node, we can see that we do in fact have kubectl configured. And if I do a kubectl config view, this is going to show us all of the clusters that are configured. Next question is asking us how many clusters are defined in the kubeconfig on the student node. So we just ran a kubectl config view, and if we go under the cluster section, we can see that there's two clusters, cluster 1 and cluster 2. The next question is asking us how many nodes are part of cluster 1. And make sure to switch to the context of cluster 1 before you actually run your commands. So let's make sure we do that. I'm going to do a kubectl config use-context and then cluster 1. And then I'm going to do a kubectl get nodes so that we can verify the total number of nodes. And we can see here that there's two total nodes, the control plane and then node 1. So I'll select 2. Next question is asking us what is the name of the control plane node in cluster 2. So let's switch to cluster 2. And I'm going to do a kubectl get nodes. And we can see that the name of the control plane node is cluster2-control plane. So this question is just letting us know that we can SSH to all of the nodes in either of the clusters by just doing SSH and the name of the node. So in this case, if I wanted to get to the control plane node of cluster 2, I would just do SSH and then the name of the node I want to go to. I'll paste that in, and that'll take us to the control plane node. And if you want to exit out and go back to the student node, you just type in exit. So the next question is asking us how is etcd configured for cluster 1? Is it using stacked etcd or is it using an external etcd server? So to do that, first of all, we're going to change to cluster 1. And the easiest way to verify this is if we do a kubectl get pods and I do a -n kube-system. If we see a pod here for etcd, that means we're using stacked etcd, which means the etcd server is running on the control plane node itself. And another way to actually check this is if I do a kubectl get, actually we do a describe pod, and we're going to describe the API server. This will have the URL that the API server will need to use to actually communicate with the etcd server. And so if that points to localhost or the IP address of the control plane node, then we know that it's using stacked etcd. And so if we take a look at the commands here, and there should be one for etcd server, and we can see that the etcd server is in fact using the localhost IP. So it's using stacked etcd because it's running on the control plane node itself. The next question is asking us how is etcd configured on cluster 2. So we're going to run the same steps, but I'm first going to change to cluster 2. And I'm going to do a kubectl get pods -n kube-system. And if we take a look at all of the pods here, we do not see a etcd pod. But this could be maybe because there's some sort of issue with the server. Let's actually SSH to the control plane node. So I'll do a kubectl get nodes. And I'm going to SSH to the control plane node. And we can take a look at all of the static pod configurations by moving into /etc Kubernetes manifests. I'm going to do an ls, and we can see here there's only 3 manifests here. So there's nothing for the etcd server. So that looks like this is most likely not stacked etcd, but we can verify that by doing a kubectl get pods ps-n cube-system. And what I'm going to do is I'm going to take a look at the config on the API server like we did before. So I'll do kubectl describe pod and then -n cube-system. And if we take a look at the configs, there's going to be a etcd server config. We can see that that is pointing to a separate IP address. So that means that we are using a external etcd server. And the next question is asking us, what is the IP address of the external etcd server used by cluster 2? Well, that's going to be the 192.33.162.21. So the next question is asking us, what is the default data directory used by the etcd data store used in cluster 1? And so we're going to go back to cluster 1. I'll change this to cluster 1. And I'm going to do kubectl get pod. And I actually want the namespace of kube system. So we're going to just do a describe on the etcd pod. And this is going to show us the configuration for etcd. And so if I go up here and we want to take a look at the --data-dir flag, this is going to tell us the default data directory. So it's going to be var lib etcd. This next question is just letting us know that we're going to need to SSH to the etcd server for future questions. And so to do that, we're just going to open up a new tab. And we're going to do SSH etcd-server. And so now we'll have a connection to the etcd server. So the next question is asking us, what is the default data directory used by the etcd data store in cluster 2? So that means we're going to have to connect to the etcd server, the external etcd server. And I'm going to do a ps-ef pipe grep -i etcd. So this is going to show us all of the configs for the etcd server. And we want to look for that same flag, the --data-dir. So this is going to be /var/lib/etcd-data. So /var/lib/etcd-data. So how many nodes are part of the etcd cluster that the etcd server is a part of? And so to do this, we want to run the command etcd-ctl member list. But if I just run this, it's not going to work. We're going to have to pass in a few connection details. And the first thing that we actually have to do is set the version. We're going to use etcd-ctl API version 3. So we'll set that environment variable. So I'll do etcd-ctl_API equals 3. It's going to set it to version 3. Then we'll run the etcd-ctl command, but we're going to have to pass in a couple things. First of all, what is the endpoint? So I'll do --endpoints equals. And you could just take a look at what that is by going to the listen client URLs. And so you can just grab this URL right here because it's listening on localhost because we're connected to it. And then we're going to have to pass in the CA cert. And that can be found right here. So if we look for trusted CA file, copy this. Then we need the cert. And the cert is going to come from here, cert file. And then lastly, we need the key. And that's going to come from this flag key file. And now we can run the member list command. And so all of these details like the endpoint, the cert, this is all going to come from just grepping the etcd process. And so when we run this, we can see that there's one entry. So there's one member in this cluster. So the next question, we have to take a backup of etcd on cluster 1 and save it onto the student node at the path /opt/cluster1.db. So let's go back to terminal 1, which is going to be our student node. And I'm going to do a kubectl config use context cluster 1. And So to do this, first of all, we have to get information about the etcd server. So I'm going to run a kubectl get pod -n cube-system, because remember, this is using etcd in stacked mode, so it's going to be running as a pod. And I'm going to do a kubectl describe pod, and then we're going to grab the etcd pod. And there's a couple of pieces of information that we're going to need. So since we're going to be using the etcd ctl utility, CLI utility, we're going to need the advertise client URL. So this is the URL that we can reach the etcd server. We're going to have access to the cert file, and we're going to need to have access to the key file, as well as the CA cert, which should be cert file, client cert, and trusted CA file. So those are going to be the four things that we need. And so I'm actually going to SSH to that node. So I'll do kubectl get nodes, and we're going to SSH to the control plane node. And here I'm going to first set the API version to be, actually, before we did, let me just run that same command. Okay, so this is, I'm just going to keep all this for reference so that I don't clear it out again. So now I can do, first I'm going to set it to version 3. And then we're going to run etcd-ctl. And the command that we want to run is snapshot save /opt/ and then we're going to save it to cluster1.db. So this is going to take a snapshot, but we have to provide all the connection details. So here I'm going to pass in the -- endpoints flag, and this is going to be the advertise URL. And then we'll do the -- CA cert. Then we want to do the -- cert flag. And then we'll do the -- key. All right, and so that should take a snapshot, and if I go to /opt, we should see it in there. And we can see cluster1.db. But the instructions say that we want to save this onto the student node, so I'm going to exit out of here. So I'm back on the student node. And I'm going to just copy that file onto the student node. So I'll do cluster1 - control plane. And that file is stored in /opt/ cluster1.db. And I'm going to save this in /opt as well. So that copied over. If I do a ls/opt, the file should be on the student node, and we can go ahead and run verification. And that was successful. So for the last question, it's saying that a etcd backup for cluster2 is stored at /opt/ cluster2.db. Use this snapshot file to carry out a restore in cluster2 to a new path of /var /lib /etcd-data-new. And once the restore is complete, ensure that the control plane components on cluster2 are running. And so what we're going to do is I'm going to go to my etcd server. Actually, first of all, let's go back to our student node, and let's just verify that we have the cluster2.db file. So I'll do ls/opt. So we have cluster2.db. So we're going to SCP this to the etcd server machine. So we'll do scp/opt cluster2.db, and this should go to etcd-server. And I'll send that to the root folder. So now if I go back to my etcd server, if I do ls, that file should be there. So now we're going to do a snapshot restore on the etcd server. So I'm going to first set the version to 3. And then we just run etcdctl snapshot restore. And the location of the backup, so it's going to be cluster2.db. And then where do we want to restore this to? I'll just say --data--dir. They want it in /var/lib etcd-data-new. And we don't need to pass in any of the certificate or the key files into this command because we're just doing a restore. So we don't actually even need to connect to the etcd server. And so this is going to run that restore. And so after that's done, if we go to that folder of var lib, and we see that file, we have to make sure that the permissions are all set. So right now etcd-data-new is set to be the root user as the ownership. So we want to change that to be the etcd user. So I'm going to do chown, and then I'll do etcd, and then we want to change that to be the etcd-data-new. So now if I do an ls-la, we should see that it's now owned by etcd. So after we make that change, let's go ahead and change the configuration on the etcd process. So I'm going to go to /etc/systemd system etcd.service. And the only thing we got to change is the --data-dir flag to point to the new folder. So I'll save that. After we make those changes, we're going to have to do a systemctl daemon-reload. And then we'll have to do a systemctl restart etcd. And let's just do a quick status. Okay, so it's up and running. And so now the last step that we have to do is we have to restart all the control plane components so that they're not using any kind of stale data. So I'm going to go back to terminal 1. And let me just make sure I'm connected to... Okay, so I'm still on cluster 1. Let me change this to be cluster 2. Okay, and so now if I do a kubectl get pods, I'm going to go ahead and restart the control plane components. So I'm going to restart the control manager and the scheduler. And we're also going to restart the kubelet process on the control plane node. So I'm going to do kubectl delete pods. So controller manager, as well as the scheduler. So now if I do kube system, let's just make sure that they come back up. All right, so now both are running, and you can see they've been restarted. We're then going to SSH to the control plane node. And we do a kubectl, sorry, not kubectl, we're going to do a systemctl restart kubelet. Okay, and so that's back up and running. So that should complete the whole backup process or the restore process, and we can go ahead and run the verification. And we can see that's complete. And so that's going to wrap up this